So the topic of the day is water. The whole planet, 71% of the planet Earth is made up of water, and that sometimes underestimates the value of water. We do not estimate the value of water till the time the wells have dried, or you ask a person who's thirsty for a very long time, or you ask a person who lives in a desert about water. So if you talk about water and diseases, bache, the water is associated with 20% of all the diseases are water associated. It could range from dehydrations, it could range from waterborne, water-based, water-related, whatever disease, but 20% are water associated. We are also talking about 3.5 lakh under 5 deaths in India which happen every year due to water associated diseases. We are also talking about a national wastage of 150 million which happens for people fetching water, coming back home, again going for water fetching, again coming back home. They could have spent that much time in something more useful for the country. So based on these facts, let us go ahead and learn about some topics in water. There are a lot of competencies which are related to this water topic, beta. You are supposed to learn describe the concepts of safe and wholesome water supply, sanitary sources, water purification methods, water quality standards, things about water conservation and rainwater harvesting. So in this whole section about water, we have divided into two parts. The first part, we are going to talk about the norms of water quality, sources, and about the water quality measurements like the physical, chemical, and biological measurements. In the second module, we will talk about the water purification system that we have in public health. Very important for your exam. Water quality, very important for your exam. Then as we will also talk about some water-related diseases and the National Water Sanitation Program and about the rainwater harvesting. So let's get on and talk about the first topic, that is water sources and the water quality parameters. So let us come to the topic number 1. What are the norms of water supply? Beta, how much water do you need every day? Don't answer me that you'll need 1 to 4 liters because some people will be there who need to take water for washing also. So what are the norms of water supply? How much water do you need? In rural areas, we need approximately 30 to 40 liters per capita in day, LPCD. Or in urban areas, we need around 150 to 200 LPCD. What does LPCD stand for? Liters per capita in day. Per capita in day. I duly understand that how much water do you need for drinking? For drinking purposes, one needs 1 to 5 liters of water depending on the requirement per person. Usually 1 to 5 liters for drinking is required. But if you talk from the municipal corporation or the municipality point of view, the water that we need under the national program for water sanitation is 30 to 40 liters per capita in rural areas and 150 to 200 in urban areas. Why do you think we need more water in urban areas? This is because there is a sewage system, and because sewage system is there, more water is required. Topic number 2, what are the sources of water? You can have different sources of water. You can have rainwater, surface water, groundwater. Rainwater is that barkha, barish, rainfall water. Surface water could be like the rivers. Surface water could be like the canals that we build from the river. Surface water could also be the sea or the ocean, but we do not use the sea or the ocean water. So we use the river or the stream, whatever you want to say, small rivulet or the stream or the canals. And we also have something called as the surface water, that is impounding reservoir. What do you mean by impounding reservoirs? MCQ, impounding reservoirs could be both. They could be naturally occurring or they could be man-made. These are some bigger reservoirs, before the dam. Have you ever been to a dam? If you go to a dam, before that big great wall of the dam, usually there is an area that is the catchment area. So you catch all the water over there and the dam is going to stop the water so that it doesn't overflow, and you make a restricted flow of the system. So that catchment area is actually an impounding reservoir. You could have man-made or we can have natural sources of the impounding reservoirs. We can use them for drinking water, but usually those are simply stored there for regulating the flow of the river. Next is, what are the sources of the groundwater? Groundwater, you can have the wells that we have in the villages, or we can have something called as tube well. So how is well different from a tube well? We are very soon going to see. Let's have a quick discussion about different types of wells first. So talking about the wells, different wells can be classified based on the material type, the depth, or the engineering or the design of the well. The material type of the well can be different, like you can either use simple soil, that is called as a kacha well, or we can have a pakka well. What is a pakka well? Common sense, I think everybody knows about it. Pakka well means there will be brick lining or some things. Based on the depth also, we can have different types of wells. Shallow wells, we can have a shallow well, or we can have a deep well. Beta, what happens in soil is different layers of soil are there. So in the soil, initially you have a soil. Below that you have some gravel, and under that you have a layer that is a solid layer. This layer is not going to let the water come down. So whatever rainfall water is there, it's there in the soil, and the gravel is there, and this is the layer of the rocks. This will not let the water trickle down. This is called as the first impervious layer. The first impervious layer is made up of some special rocks. And then you have again some areas like there will be a lot of gravel, there will be sand in the earth. And below this sand in the earth, beta, there will be another rock layer, which is bigger one. This is like a more bigger one. This is called as the second impervious layer. Second impervious layer. And below it, you have again that gravel, and there will be groundwater. So you'll have a groundwater below the second, you'll have a groundwater below the first, you'll have a groundwater above the first also. So the wells which are located technically above the first impervious layers, they will be called as shallow wells, or you will have deep wells which may extend below the first or even below the second impervious layer. How deep the well is, that is going to define whether it's a shallow well or it is a deep well. Next is the wells can also be based on the engineering designs. What do you mean by engineering designs? That different wells can be there. One is a simple well that we all know. You dig the well. So that is digging inside the earth. That is a well which is called as a dug type of well. Next, you can also have something like a tube. You put a tube inside, and through the tube you make the water come up. So that is called as a tube well. There is another type of well that is called as artesian well. Artesian well is usually between two high pressure zones. So it is between two high pressure zones. Very soon I'm going to talk to you what do you mean by all these. So now let's just take a look at all these different types of wells using some images. It's so easy always to have a look at the images and then understand the MCQs, right? So what do you see over here, beta? I see a simple well over here, and of course the well has been dug inside the earth, so it's a dug type of well. MCQs on this. MCQs on this. Beta, there are three MCQs. First, what do you mean by a sanitary type of well, and what is a non-sanitary type of well? So what do you mean by a sanitary well, and what is a non-sanitary well? Non-sanitary well. Sanitary well means that it is well covered. It is complying to all the public health requirements of being called as a well. So what are the public health requirements? Beta, a well should always be covered from the top. First MCQ. It should always be a pakka well. It should have a covering, right? You can see, I don't know if it's there on the screen. It's a very small mesh net covering they have done. So there is a covering. It should be a pakka well. It should be lined with a brick line. Third, there should be always, where you dig the well, there should be a parapet. There should be a structure which is above the ground so that the children don't run and they fall inside, or the animal, cow doesn't fall inside, or the dog doesn't fall inside. So there should be a kind of berm over there. The boundary wall should be there. So the boundary wall should be the boundary wall, or the height of this boundary wall should be more than 3 feet. Usually around 3 feet. If it is very high, the females or anybody, the male also, it will be difficult for them to pull up the water. If it is very low, they'll have to bend it down. So it's usually around 3 feet. And the well over here, I don't know if it's visible to you. Can you see that the well has a pakka? If this is the well, if this is beta the well is having a pakka area over here. It is a cemented area. it should be a cemented area. Why? Because the soil should not be there. Because if the soil is there, if this is not cement, the water will form a tunnel inside. Are you getting it? The contamination will go inside and the contamination will contaminate the well. Are you able to get hold of it? So it's always advised that the cement should be there so the contamination may not enter into the well system. How much should be the cemented part of the well? Please note MCQs bache. The radius of the cemented should be 3 feet. So it's super easy to remember. The height should be of the parapet should be 3 feet. The cemented lining should be 3 feet. So you can say in Hindi we say the 30. The 30 should be the area around the well should be 3 feet and the well boundary should be 3 feet. So the area, it should have a cemented ground near it, and the cemented ground should be more than 3 feet in radius. So that well is a sanitary well. Next in line, it's also important that the water quality should be checked. The water quality should be checked. There should be appropriate chlorination of water. And it should be safe to drink. Safe to drink. The water should be away from any harmful substances. There should not be heavy metals. There should not be very high hardness value or the equivalent of hardness. We are going to study everything. But I just wanted to tell you this is what we call as a good sanitary well. What do you mean by a non-sanitary well which has no cemented wall? It is a kacha well. All these are non-sanitary wells. So what is a sanitary well? A sanitary well is any well which has all these public health measures. What you see over here is, beta, this is a pakka well. You can see the brick lining. This is a pakka well. You can see the brick lining, and probably there is area for people to come and maybe clean the well also. So this is a very deep well, and this is what we have as a pakka well. What is this type of well? This you must have seen during Ramayana or Mahabharata, of course, in the TV episodes. You were not there during Ramayana or Mahabharata. What is this type of well? This is called as a step well, where people used to go inside the well. Now that is a problem. You just step down inside the well. That is a problem because people with different diseases or with different microorganisms on their body, they are going to enter the well. So actually you are having a very high bacterial load in cases of step well. They are never advocated. In fact, they have been stopped now. We have something called as a sanitary well, which is usually a single dug well. What is this over here? What do you see here? This is what is, I think everybody in the villages, if you happen to go anytime, you have a hand pump and you have a tube well. So these are like tubed wells, or these are called as, they are categorized in the category of tubed wells or the tube wells. So this is what is the general hand pump we have. It is above the first impervious layer. It is very shallow. So you can have a very shallow kind of tube well, or you can have a well which is a deep tube well. It goes deep inside. So once it goes deep inside, the problem with these deep tube wells is that they won't be able to pick out water very fast. Like you'll have to put a lot of energy to put it that way, right? The water has to come up. So what we do is, any deep tube well, we have stopped using a manually operated deep tube well. We have a powered operated deep tube wells, and this is what I think everywhere if you happen to go in villages. I spent my childhood in playing with tube wells and playing with water through the tube wells. It's a motorized system where you have a lot of water coming in and you can enjoy your time. So that is what is a tube well, which is a motorized tube well, right? What do you see over here, beta? This is artesian well. This is an artesian well. The benefit or the MCQ which you can get is that the artesian well is never going to dry. The shallow wells will become dry, the deep wells will not become dry. The deep tube wells will never become dry, the shallow tube wells will become dry, right? The artesian well, even if it is shallow, it won't be dry. Why? Because very simple. What happens is, you can start this from point number 3. This point number 3 is a raised thing, and this is called as a recharge area. This is called as a recharge area where the rainfall is there. Now what happens is, if the rainfall is there on one, if this is the mountain and a mountain, so if the rainfall is here and the rainfall is here, so beneath the first impervious layer, the water will get trapped. Are you getting it? The water will get trapped because the water cannot go down. It cannot pass that impervious layer. So it gets trapped. Now if you dig a hole over here, that is what this is. If you dig a hole over here, even in the superfluous layer, you will have water all the time. Why? Because there is a constant recharge areas. There's a lot of rainfall on this side. If there is rainfall on this side and there is first impervious layer. So now below this first impervious layer, there is water, but point is that above the first impervious layer also there is water because there is recharge coming from sides. So just another way to look at this artesian well is that this is the rock layer, this is also impervious layer. This is the rock layer, this is also impervious layer. So now if you put a hole over here into the below the first impervious layer, which usually will have some amount of water but may also dry. Now this artesian well is never going to dry because there is a recharge area. There is a recharge area, and that is what is the benefit of artesian well. They will never dry and they are under high pressure. Usually in India, we have very few types of artesian wells in the world. There are only some areas in North America, in Canada, where you have many artesian wells. In India, it's usually not there. So that was just a brief introduction about what are the types of wells. Let us come to our topic now. Topic number 3, which is a 5-star MCQ topic. The real MCQs start now. What are the water quality parameters? Beta, the water quality parameters can be assessed in 3 levels. You can talk about the physical quality, we can talk about the chemical quality, and we can talk about the biological quality of water. How do you assess the physical quality of water? How do you assess the physical parameters? The physical parameters of water can be assessed by color, odor, turbidity, temperature. These are the physical parameters of water. So the water should have a reasonable color, odor, turbidity, and temperature. So talking about the first thing about the color, how should be the color of water? Don't answer me that the color of water should be colorless. If it is colorless, then what is air? Air is colorless, and that is the reason I can see some things over here, because things are not getting changed. You remember refraction, rarefaction. So color, there is some particular little color of water. The color of water should always be less than 15 TCU. What do you mean by TCU? True color units. More than 15 TCU, it is not permissible. So up till 15 TCU, it is permissible. Less than 5 TCU, it is ideal. So the ideal color of water should be less than 5 TCU. After 5, there will be some color, where there will be some visible, noticeable change in the color. And that's what is important for you to know, that the permissible is 15. 2 MCQs beta. Permissible limits of water, color in water, 15 TCU. What is the ideal limits of color in water? 5 TCU, less than 5 TCU. TCU stands for true color units. Water is not colorless. Next is, what do you mean by odor? Odor means the smell or the fragrance. The water should have no odor. It should be odorless. It should be odorless. There should not be any odor. Next in line is, what are the chemical parameters, beta? Chemical parameters, one of the 7 by 5-star MCQ topic. It is most commonly asked, in fact, a very frequently asked question. In fact, even if you want to skip this module, in this module, I would never recommend you to skip at least the topic of chemical parameters. In chemical parameters, bache, we need to talk about 3 things: chlorination, hardness of water, and some other clinical parameters, or the chemical parameter, not the clinical, other chemical parameters. So in chemical parameters, we will talk about chlorination, hardness, and other. Chlorination, let us start with the first one, chlorination. MCQs on chlorination, and chlorination is what is the 7 by 5-star MCQ topic. So MCQs on chlorination. First MCQ, what do you mean by chlorination? Chlorination is disinfection or pasteurization or sterilization. What is chlorination? Chlorination is, please note, disinfection of water. Disinfection of water. How do you think that chlorine acts in water? What is the mechanism of action? Mechanism of action of chlorine. Mechanism of action of chlorination. How does it purify, or how does it disinfect the water? So the mechanism of action of chlorination is by formation of something called as free radicals. Mark every word very carefully in your copies or in your notes, or if you're writing it, make sure you underline every word, because every word is MCQ beta. Mechanism of action of chlorination is by formation of free radicals. Highlight it. Which are the free radicals which are going to form? There are 2 free radicals. It is the hypochlorous ions and the hypochlorous hypochlorite ions. So there are two ions which are formed, hypochlorous ions and the hypochlorite ions. Hypochlorous ion is the main mechanism. The main action is under the hypochlorous ions. The main action is by the hypochlorous ion. How does this hypochlorous or the hypochlorite ion form in the water? How do they form? Now you need to understand what is the third point. What is the principle of chlorination? What is the principle of chlorination? Please note that if this water, let us say that this water is here in this bottle, and let's assume that this is fecal contaminated, right? It sounds so bad to hear about it, but because I was drinking this water, but let's say this water is fecal contaminated. I want to chlorinate it. Why would I chlorinate it? You're scared of what in water? You're scared of the microorganisms. Which microorganisms? You're scared of the Escherichia coli or the coliforms. So you're technically scared of the microorganisms which are anaerobic or the coliforms. So if you add chlorine in this water, what do you want? What do you think? That adding chlorine will cause disinfection? Answer is no. What happens is, beta, that if let us say this is the water, in this water, if I add chlorine at this point, chlorine will not cause chlorination. The chlorine will go instead and mix with the ammonia compounds in this water. So the chlorine reacts with the ammonia compounds in the water and it forms all the organic material and the ammonia compounds, ammonium compounds. It will react with these compounds in water. Where does the ammonium compound come from? The poor fecal bacteria or the coliforms or the anaerobes. What is their byproduct? Their byproduct is ammonium. So the chlorine will react with the ammonium compounds and form lot of chloramines. So what happens is you add chlorine to water, the chlorine with ammonia, chloramine. So chloramine. You are human. You can add as much chlorine as you want. But that poor bacteria had a limited amount of ammonium. Now at certain point, there is no more ammonium. Now at this point, if there is no more ammonium, now if you add chlorine, if you add a chlorine, which is a negative ion, so if you now add chlorine, now that whole game starts. See, somebody must have beautifully thought on this and found that chlorine actually reacts in this manner. And that's what we are doing now. So now if you add extra chlorine, this extra chlorine, what is there after there is no ammonium compounds, it is going to destroy the chloramine. So what are the products of the destruction of the chloramine? There will be residual chlorinated compounds. So the residual chlorinated compounds could be of two types. They could be the free residual compounds or the free chloride which are there, or we can have the combined residual chloride compounds, which that is the chlorine could have combined with other non-harmful or the harmless compounds. So one is that chlorine is there in the water as free chloride residues or the chlorine residues. These are called as the FRCs, or we can have the combined chlorine that is called as the combined residual chlorine. There is a third thing which can happen. The chlorine which was there, it will be liberated out, and this is like a free chlorine which just evaporates very fast, right? There is a third thing which happens is that the extra chlorine which is there, it may also combine with some of the impurities in water. It will combine with the impurities, with some of the salts. It will make some chloride salts. So this whole thing, let me just simplify what is going to happen at this particular junction. So I am at this junction now. Let me just zoom into it and make it in a separate page what is happening at this particular junction where the things have started breaking. At the breaking, you will have formation of the free residual chloride compounds, free residual chlorine compounds. You will also have a combined chlorine compounds, and we will also have formation of the chlorine with impurities. Impurities in water or some of the metals in water, the chlorine is going to combine and going to stay there. And some, of course, will be like the 0 point, you can say, will be liberated free. It will just evaporate. It will just go off. That is what is the chlorine gas. So these are the things which are going to happen. Now what happens is this free residual chlorine. Now this free residual chlorine, it combines with water. So the chloride negative ions will combine with water and they will cause the formation of the hypochlorous ions and the hypochlorite ions, and these are what are the free radicals. So now do you understand? Let me just take you back to this game. Now do you understand that adding chlorine to water does not cause disinfection? Adding that much chlorine to water, which causes a breakpoint chlorination, beta. What is the breakpoint chlorination? This is the breakpoint. What do you break in a breakpoint chlorination? The chlorine will start destroying the chloramines. So this point is called as a breakpoint chlorination. This point is called as a breakpoint chlorination. So always if you achieve a breakpoint chlorination, only then there will be formation of the free residual chlorine, the combined chlorine, the chlorine with impurities and liberated free. Liberated free does not do anything. The residual chlorine, the free chlorine, it is going to combine with water and cause the formation of free radicals which are going to exert the disinfection action. So that means it's such a wonderful phenomena that adding chlorine in water will mix with some of the components by the excreta of the bacteria and will generate some components which are going to kill the same bacteria. Again, after some time, this is the principle of chlorination. So a lot of MCQs I have discussed over here about the principles of chlorination. First MCQ is, how much chlorine to be added? This is given by what? Will this be given by the quantity of water or will it be more dependent upon the contamination level of water? Common sense, it will be dependent on the contamination level of water. So how will you tell, what is going to tell you that how much chlorine to be added in water? That is being told by what? That is being told by an apparatus that is called as Horrocks apparatus. So what is this Horrocks apparatus all about? Horrocks apparatus is going to tell you about the chlorine demand in water. It is going to tell you that how dirty the water is, how much chlorine is to be given. This is going to tell you about the chlorine demand. So for your MCQs, please note that the chlorine demand is given by the formula. It is given by the formula amount of chlorine which is added to water. Amount of chlorine which is added to water minus the amount of residual chlorine in water. This is going to tell you amount of residual chlorine in water after 60 minutes, after 1 hour. This is what is going to give you the chlorine demand. And this chlorine demand can be grossly assessed using an apparatus called as Horrocks apparatus. So that's the formula. Let us have a look at what Horrocks apparatus is all about. If you look at this Horrocks apparatus, beta, in a Horrocks apparatus, there will be one cup which is black color. There is a one black color cup. Can you see over here? There is a black color cup. And then there are six cups which are white color cup. There is in the Horrocks apparatus a special reagent that is a starch iodide. And there are some stirrer, and there is a spoon also. So what we do in Horrocks apparatus is we take the first cup, that is the black cup. In the black cup, you are going to make a solution that is called as a stock solution. You make a stock solution. What is this stock solution? Very important for your MCQ exams, especially for PG aspirants. This has been asked multiple times that how do you prepare a stock solution? The stock solution you're going to prepare with 2 grams of bleaching powder. So you mix 2 grams of bleaching powder with some little water that you have and you make it as a thin paste. Right? Very thin paste. And now what you do is you take the different 6 cups are there. In the different 6 cups, you are going to put the water that is supposed to be tested. So in the first cup, you will put 1 drop of the stock solution. Then in the second cup, you put 2 drops, 3 drops, 4, 5 and 6. So different cups will be there. First, second, third, 4, 5 and 6. In the first one, you put 1 drop, 2 drop, 3 drop, 4 drop, 5 drop and 6 drops. So different drops you are going to put. Now what happens is, so now what we do with this Horrocks apparatus, let's have a look. In case you are a UG student, definitely you should be knowing how to use the Horrocks apparatus. In case you are a PG aspirant, at least you will get some 1 or 2 left and right MCQs over here. Let's just have a look. So what we do is we take the first is the black color cup. First we take is the black color cup. In the black color cup, at first step, what are you going to put? You are going to put 2 grams of the bleaching powder. MCQ. You put the 2 grams of bleaching powder in the first cup, in the black color cup. In this black color cup, you put some water and then you just make it a thin paste, and then you keep on adding water. You make it as a liquid till a mark is there in that black cup. So till the mark, you keep on adding water. So this water and the bleaching powder that you have put, this is now known as a stock solution. This is called as a stock solution for checking the chlorine demand. Now what you do is you take all the 6 cups. There were 6 white color cups. So you have 1, 2, 3, 4, 5 and 6. In all the 6 cups, you put water, which is supposed to be tested. All the 6 cups will have water, which is supposed to be tested. One source of water. Don't put different sources in different cups. So one source of water which you want to test, you put in 6 different cups. In the first cup, you put 1 drop. In the first cup, you put 1 drop of the stock solution. In the first. In second, you put 2 drops, then you put 3 drops, 4 drops, 5 and 6 drops. Then you wait for, after putting all the drops, 5 drops, 4 drops, 5 drops and 6 drops. After this, you wait for half an hour. Half hour, you wait. Once you wait for half an hour, now you will put some reagent which is going to give you the color change. What is the name of reagent? Again, MCQ. That is starch iodide. You use a starch iodide. So a starch iodide is going to give you what color? Blue color. So now you put starch iodide. How much you put? You can put usually 3 drops of starch iodide we put. So now you put 3 drops of starch iodide in every cup. Whichever cup is, now that is again MCQ beta, whichever cup, let us say cup number 3 gave you a color change. Of course, it's a green color. It should be a blue color. Let us say the third number cup is going to give you the blue color. Let us say there is a change in the blue color in the third cup. What does that mean? So that means you had taken 2 grams of bleaching powder and 1 drop in every 1 drop, 2 drop, 3 drop, 4 drop. So the third cup, that is the 3 drop cup, was showing you the color change. So what does that mean? That beta mean if the third cup is showing, so what you do is 2 gram into the number of the cup. Number of the cup, that is 2 into 3, that is 6. So now you need 6 gram of bleaching powder for disinfecting 455 liters of water. 455 liters of water, you need 6 gram. How did you calculate? 2 gram of the bleaching powder into the number of cup. This is again your MCQ. So beta 2 to 3 MCQs can come. How to measure the chlorine demand using a Horrocks apparatus? You take a black cup and then you put the different drops. So that was regarding the principle of chlorination. So how do you do chlorination? First is we find the demand of chlorine. That is called as chlorine demand. Chlorine demand is given by Horrocks apparatus. Once the Horrocks apparatus tells you that much chlorine is to be added, let's take for example, 4th cup gave you the color change and you had 1000 liter of water, one big tank of water. What does it mean? How much chlorine to be added? 8 grams of bleaching powder to be added to 500 ml of water, 500 liters of water. So for 1000, you need 16 grams of bleaching powder. Very simple to understand. Did you get that? So that's how you're going to calculate. So that is about the Horrocks apparatus. Now Horrocks apparatus tells you how much chlorine to add. You tell me how to add chlorine. So how to add chlorine? Can you find it out? How to add chlorine? To add chlorine, you will have different options. Adding chlorine can be done as you can use a bleaching powder. So to add chlorine, first we can do is we can add bleaching powder, or we can also add perchloron, or we can also add chlorine gas. MCQs on these. What is bleaching powder? What is the normal household bleaching powder? That is called as the sodium hypochlorite. Sodium hypochlorite, that is the household bleaching powder. What is perchloron? Perchloron is the commercially available calcium hypochlorite solution. It is also called as a high test hypochlorite solution. So these are like two different names of the same thing, perchloron. Usually at the commercial levels, at the municipality levels, we are either using perchloron or we can use the chlorine gas. The chlorine gas can be available as direct chlorine gas or the chlorine dioxide gases, but usually in most cases we are using chlorine gas. These come in amber or yellow colored cylinders. Yellow or amber colored cylinders will be there for the chlorine gas. Next MCQ, bleaching powder is going to give you how much chlorine? Please note, bleaching powder will give you 33% free chlorine. Bleaching powder will give you 33% free chlorine, and perchloron will give you 66% free chlorine, and chlorine gas common sense will give you 100% free chlorine. So that is what you need to remember about the second point about different ways to add chlorine. So that is done about how to add chlorine. You can add using bleaching powder, perchloron or the chlorine gas. Now as you add chlorine, don't you think that you should check that how much chlorination, has it achieved that breakpoint chlorination, yes or no? So yes, technically we should also do chlorine level estimation. You should also do a chlorine level estimation. Now comes your point, how to check for the chlorine levels. The chlorine levels in water should be checked using a chlorimeter or a chloroscope. Usually in public health, we are using a chloroscope. Chlorimeters are different instruments. We are using chloroscope. So in chloroscope, we can use a reagent that is called as orthotolidine. Beta, the orthotolidine is going to tell you what? The orthotolidine is a chemical reagent which is going to find out chlorine. Now the problem with orthotolidine is that this orthotolidine, you remember I told you orthotolidine or the chlorine after breakpoint, it is going to form the free residual combined or the chlorine salts with impurities. So now the problem with orthotolidine is that it is going to check everything together. So it tells you about the free chlorine, about the combined chlorine, about the impurity based chlorine, everything together it is going to tell you. That is what is orthotolidine. If you put orthotolidine in a water, it is going to tell you whatever type of chlorine is there. Now the problem starts that in some waters, we have seen that there is more chlorine salt with more impurities. Why? The impurity level was particularly high with the chlorine. So in the water, if the impurity levels or the heavy metals, they are more in water, don't you think that sometimes the orthotolidine may be high, but in reality, the free residual chlorine, which was the main disinfectant action, it was not there. So don't you think that is going to give you a false positive chlorine test? So a better test than the orthotolidine is what we do is we play around with orthotolidine. That is called as a orthotolidine arsenate test. Arsenate test. What is arsenate? Arsenate is another chemical. We use sodium, that is the Na, sodium arsenate. We use a sodium arsenate. What does sodium arsenate do? It actually dechlorinates the water. So once you chlorinate the water, then you do orthotolidine, then you dechlorinate. So that minus that is going to give you a better result. The orthotolidine arsenate test is a better test than OT test, simple OT test. Why? Because orthotolidine had that problem of giving you everything together. It tells you about the free residual chlorine, it tells you about the combined chlorine, it tells you about the impurity mixed chlorine all together. It tells you about the together, everything together is being given by the orthotolidine test. What do we do in orthotolidine arsenate test? It is going to give you the free residual chlorine and the combined chlorines as separate values, we can find out the orthotolidine arsenate test. So finally, let's just summarize everything what you have done in chlorination. Chlorination is a type of disinfection. The mode of action, the primary or the main mode of action is a hypochlorous ion. The breakpoint chlorination means formation of the free residual chlorine and the combined chlorines, and also chlorine is there sometimes mixed with impurities. and chlorine demand is measured using Horrocks apparatus. In that, whatever number of the cup you get, number of cup with the color change multiplied by 2 is equal to the amount of chlorine, whatever X amount of bleaching powder for 445 liters of water. You can add chlorine gas, which is 100% chlorine. You can add a perchloron, which is 66% chlorine, or we can add the household bleach, which is 33% free chlorine. You can do chlorine estimation using a OT test or a OTA test. What is the advantage of OTA test? It tells you about the free and the residual separately. Free residual chlorine and the combined residual chlorine are given separately. OTA test. Last point, what do you mean by the level of chlorine? What should be the level of chlorine? And this has been asked 100 and 1000 times. Level of chlorine in water. How much should be the permissible limits of chlorine? Please note that the levels of chlorine in potable water or the drinking water, it should always be more than 0.5 parts per million, which is corresponding to 0.5 milligrams per liter. 0.5 parts per million after a contact time of 1 hour. So please note, this is what is the permissible levels of chlorination and the chlorine in water. This is what you get as a chloroscope. So in the chloroscope, this looks like a hemoglobinometer, right? So in the chloroscope, there is a different color change. You add OT reagent, there is some color change with the free or the immediate chlorine, and then there is a permanent color change because of after 4 or 5 minutes. There is a permanent color change which is because of other combined chlorines or the impurity mixed chlorine. OTA test will help you differentiate between the free residual chlorine and the combined chlorine. Now let us move to the next part of the chemical quality of water. Beta, we are discussing the quality of water. In the quality of water, we discussed about the physical parameters and the chemical parameters. We discussed one, that is chlorination. We have done about chlorination. Now let us talk about the hardness of water. So you are talking of this point. Hardness of water. How do you measure hardness of water? The hardness of water can be of broadly two types. You can have a temporary measure of hardness, or we can have a permanent measure of hardness. The temporary hardness of water can be because of the calcium or the magnesium carbonates or the bicarbonates. They can be because of the carbonates or the bicarbonates, whereas the permanent hardness is because of the calcium magnesium sulfates or the phosphates. Calcium magnesium sulfates or the phosphate, that is what is permanent hardness of water. Please note that 1 milliequivalent of hardness is equal to 50 milligrams of calcium carbonate. 1 milliequivalent is equal to 50 milligrams of calcium carbonate. That is your point number 2 to remember. Point number 3 to remember. Another point is, how do you measure hardness? Please note that if the water hardness is below 1 milliequivalent. What do you mean by below 1 milliequivalent? That is less than 50 milligrams of calcium carbonate. If the water hardness is less than 1 milliequivalent, that is called as a soft water. If it is 1 to 3 milliequivalents, that is called as a moderately hard water. If it is 3 to 6 milliequivalent, it is called as a hard water. If it is more than 6 milliequivalents, that is called as a very hard water. So what is the permissible limits of drinking water? We always use which water? We always use a moderately hard water. We cannot drink a soft water. We cannot drink a hard water. What we always use is moderately hard water. So next is point number 4, that how do you treat the hard water? You remember from your previous lecture when we talked about wells. The wells could be shallow wells or deep wells. Common sense, if the deep well is there, if it is below the second impervious layer or even above the second impervious layer, there can be more metals into the water because the water is there from the soil. So now there could be hard water from the wells. How to treat the hard water? The first thing that we can do is a very common method, easy method, that is boiling. But the problem with boiling is that the boiling has to be done for considerable time. First is it decreases the quantity of water. Half of the water you boil, so it increases the evaporation level, right? So one is that the water boiling is energy consuming. So that is very expensive, and also you lose the water quantity. So all the more it is all said and done, it is expensive. So what we do normally at commercial levels is we take the lime or the soda ash or the permutate process. Lime or soda ash can be added at the rural levels or small community level. We can add lime and soda ash. They all will decrease the total hardness. The calcium, magnesium salts or carbonate, bicarbonate, sulfates, phosphates, everything will decrease. And this is what we use at the commercial levels, or at large scale we are using the permutate method or the sodium zeolite method. In this sodium zeolite, these are the zeolite ions. So that is the disodium, dialumine, Na2, Al2, Si2, or the zinc 2. So you can combine a lot of heavy metals. They will actually be working as zeolites. They will be chelating the calcium magnesium salts. So that is how we treat the hard water. So now let's take up the third portion, that what are the other chemical parameters. Beta, the other chemical parameters that we may talk, other chemical parameters after we have talked about the chlorination and hardness. The first is the chlorine levels. The chlorine levels in water, we already talked, should always be more than 0.5 parts per million after a contact time of how much? Of 1 hour. Second, I wrote this chlorine levels again because I wanted you to understand that there is a difference between the chlorine levels and the chloride levels. The chloride levels in water should always be less than 250 milligrams per liter of water. Third important thing that you would like to remember is the TDS. TDS stands for the total dissolved solids. So TDS stands for the total dissolved solids. In water there could be, what do you mean by the TDS? It is some of the inorganic chemicals, or we may even have some organic material which acts as these are small fine solute particles in water. So the total dissolved solids in water, they should be less than 500 to 600 milligram per liter of water. So that is the reason we always say that sometimes in your RO filters, the RO filter wala will come and say that, sir, in your RO the TDS is coming as 200. So we tell him that, sir, the body should be taking some of the inorganic minerals or the inorganic chemicals. It should be less than 500. Ideal is to keep less than 300, but till 500 it is permissible. Next, you should also know about some other chemicals, that is the nitrates and the nitrites. Beta, nitrates and the nitrites. The nitrates, the value, they both, nitrate and nitrite, they both tell us about the fecal contamination, about the organic matter contamination. So organic matter is going to yield nitrate and the nitrite. So many states and union territories are there in our country which say that nitrite should be negligible, should be almost zero, should be less than 1. Because nitrite is more specific for organic contamination. The nitrite should always be negligible. It should be less than 3 milligram per liter. The nitrate, the guideline value is to be less than 50 milligram per liter in that particular water. For nitrate and nitrite, there could be another MCQ which may come in your exam, that if we talk about the nitrate and nitrite, there is something called as the ratio of nitrate to nitrite. Why? Because both nitrate and nitrite, they tell you about fecal contamination. So what we have done is, we have made a ratio of the concentration of the nitrate in the water. Concentration of nitrate in water divided by the guideline value of nitrate, common sense, in water. So that is concentration of nitrate divided by the guideline value of nitrate, and then you add it with the concentration of nitrite. Wonderful answer, na? Concentration of nitrite divided by the guideline. What do you want to say? Say it with me. Guideline value of nitrite, common sense. So you add them. So the ratio of the concentration to concentration of the guideline of the nitrate divided by guideline value of nitrate plus the concentration of nitrate divided by guideline value of nitrite. This, if it is less than 1, that is we call as permissible level. And most of the states in the country, they have set this level as very important level, nitrate to nitrite ratios. Next is about the fluoride levels. How much should be the fluoride levels? Beta, the fluoride is also known as a double-edged sword. Double-edged sword. Why do we call it as a sword? Which is double-edged? You eat less problem, you eat more, bigger problem. So the fluoride levels, what is the permissible limits? In the drinking water, it should always be less than 1 part per million. What does it mean? That what is the range in the permissible limits of fluorides in water? In water, it should be usually in the ideal range, right? So the drinking water should always be less than 1 ppm. That is what is the permissible limits. The ideal water should have 0.5 to 0.8 milligram per liter of water of fluoride. So why do we say 0.5 is the upper limit? Because that 0.5 is the limit. Because if the person gets water and the fluoride in that water is less than 0.5, there is problem of fluoride deficiency in the people. So if it is less than 0.5, it may land up into fluoride deficiency. What do you mean by fluoride deficiency? The person may have dental caries. And if a person is eating more than 0.5 in the water, if the person is getting more than 0.8 milligram per liter of fluoride, then the person is exposed to fluoride excess. In the fluoride excess, what will the problem happen? The person may land up into fluorosis. So in case there is fluoride deficiencies, there will be dental caries. So in case the population is having fluoride deficiencies, the government or the state government or the public health authorities over there, they will help in fluoride supplementation. They will help in fluoride supplementations of the water or of many food products. In case of fluoride excess, the water needs to be treated for fluoride, that is using a technique called as Nalgonda technique. So Nalgonda technique is for defluoridation. It is for defluoridation of water. Nalgonda technique. So please note that fluoride is a double-edged sword. Less than 0.5 problem, more than 0.5 bigger problem. It is a double-edged sword. You eat less, big soup. You eat more, it is a bigger problem. So this is what is the summary of the chemical contamination or the chemical quality of the water. The chloride level should be please note, it should always be less than 250, and the chlorine level should be more than 0.5 parts per million of a drinking water. The optimum pH is 7.5. The total dissolvable solutes or the solids should be less than 500-600. Total hardness, we have already discussed, it should be range between 1:3. Less than 1, soft water, not good. More than 3, hard water, not good. Iron level, calcium level, sulfate, if you can remember, you should. But otherwise, nobody will ask you at least in your MCQ exams. Nitrate and nitrite, you should remember. So finally, we were actually discussing about the quality of water, and we discussed about the physical parameters, the chemical parameters, and now let us talk about the biological parameters in water. So what are the biological parameters in water or the microbiological aspects in water? Please note that the microbiological aspects in water is measured using what? Don't answer fecal streptococci or anything else. Please note that the microbiological aspects in water is measured using coliform test. You do it, the most sensitive criteria of talking about any biological contamination, that is E. coli. E. coli, Escherichia coli is the most sensitive test for biological contamination of water. It is the most sensitive criteria for biological contamination of water, that is the coliform test. MCQs on coliform test. Beta, to test coliform, we will take a water sample. And the water sample is taken and we do a coliform test. What is the way to do a coliform test? The way to do a coliform test, that is called as a McCartney chart method test. McCartney chart method test. In the McCartney chart method, what is the technique that we deploy? What we do is the most probable number method. So what we do is, I'm just telling you briefly, overview, the gross phenomena, what we do in a McCartney chart method is, of course, it's from microbiology point of aspect for you to know. But what we do in McCartney chart method, beta, is that we take different tubes. So different public health labs will have different levels of McCartney charts. So for example, I take 5 tubes. So 5 tubes, 5, 5 and 5. So 5 tubes in one row and 5 in one column. So total will be 25 tubes. You will titrate the water and add it to each one, and there is already a liquid broth in that. So you add water, and after adding water, there could be some coliforms which will grow on that particular agar, the liquid culture which was already there. So then you check for what? You incubate for 24 hours. You incubate for 24 hours, and then we are going to check for gas and color change. So in case you get a gas and a color change, then we are going to say that yes, coliform has been found. There are certain situations where the coliform test may be falsely positive. Why? Because there could be gas and color change because of presence of Klebsiella. So sometimes there could be Klebsiella which is present. Klebsiella may contaminate your results or may cause a false positive result. So therefore, to rule out Klebsiella, we do a test called as Ejekman test. So what is this most probable number, and what is this McCartney chart? What is this Ejekman? What is this Ejekman test? Please note that in the most probable number, 25 test tubes are there. You add these things. So there is a chart. There is a chart that you find color and gas change in how many, in which one you find. That is why we call this method as a most probable number. This method is using a chart called as McCartney chart. Sometimes you may get a falsely positive because of the presence of Klebsiella, and because of Klebsiella, you have to do Ejekman test, which is going to rule out Klebsiella from the coliform test. So this is what is biological testing of water. This is what is the microbiological aspect. Once you do coliform testing now, there are certain situations where you might say there is a recent contamination. There is a recent contamination, or there could be a remote contamination. A recent contamination or a remote contamination. What do you mean by recent contamination? Recent means just nearby contamination. So recent means just nearby contamination. Remote common sense will mean distant contamination, hai na? Remote will mean distant contamination. So if there is a nearby contamination, that means some contamination is happening very near. So what is the microbiological or the indicator for this is, you can check for the fecal streptococci. Fecal streptococci is an indicator. It is an indicator for recent contamination or nearby contamination. And in case the water is contaminated far away or a distant contamination, then the indicator we can take is Clostridia perfringens. Clostridia perfringens. So we can take Clostridia perfringens as the indicator for distant contamination, remote contamination, distant contamination. Nearby contamination is recent, that is fecal streptococci. Otherwise, if you get the most sensitive test, what we do is coliform test. So now, after having discussed the physical, chemical and the biological parameters of water quality, let us talk about the radiological aspects of water quality. The radiological aspects of water quality can be measured in 2 areas. You can talk about the alpha activity, or we can actually talk about the beta activity. Both are important. We can talk about the alpha or the beta activity. They are measured in the becquerels per liter. The alpha activity should be less than 0.5 becquerels per liter, and the beta activity should be less than 1 becquerel per liter. So that is all about the radiological activity. So with that, you have completed all the quality parameters of water. In the next video module, we will discuss about some of the water purification methods, National Water Sanitation Program, and a little bit things about the rainwater harvesting. Thank you so much for watching this one.
Hi guys, please subscribe my channels.